This question is called probability of a triangle, and it says a stick is cut twice randomly. Each cut point follows a uniform distribution on the stick. What is the probability that the three segments can form a triangle? So the key terms here are they're cut randomly, obviously, and also important thing is uniform distribution, the fact that the probability of any cut point is equal. So we're going to create two random variables, x and y. X is going to tell us point on stick, or yeah, point on the stick that was cut. And again, here's also a point on stick that was cut, because there's two cuts, right? And random variable, just a quick overview, is a mapping or a function that maps an outcome in the outcome space to a number. So an outcome space can contain, the stick, like it can contain like words. It can be like, it can say the stick, the stick was cut at 0.3 meters. Let's say if it's a 1 meter stick, and x of this maps that whole outcome to 0.3. Okay, so now we just get to have a variable that just tells us numbers that we care about. All we care about is numbers in this case, and that's the numbers that it was cut at. Okay, so now let's create our stick. This is a stick. And let's say it's 1 meter long. We can just, because we're dealing with probability, and saying it's 1 meter long is allowed because we're trying to care about the probability of like a unit stick basically, and that can apply to all sticks. Okay, so we get to keep generality in this case. So 1 meter, we just say 1 meter is fine. Okay, so we can have two cuts, right? Call it x and y. That's one case, the case where the cut for x is on the left. We also have to address the possibility of the cut for y or x being on the right. Right? Y and x. Okay, so now what are the lengths of these triangles, of these like portions on the stick? Well, if the stick was cut at a point x, right? Let's say let's say it was like 0.3, for example. This is like 0.7, for example. Then you would say, okay, from the left to the cut point is the length, right? You would say it's 0.3. In this case, you would say it's x. And then again, for the middle portion, you would say this portion, it's 0.4. It's y minus x, right? So then you would write y minus x. And here, if the cut point is at 0.7, right, and your whole stick is 1 meter, then you would say 1 minus 0.7. But in this case, you would say 1 minus y. And we can repeat that same thing for this other stick that we made. You can say y, x minus y, and 1 minus x. Again, this is, I can't draw these, bro. Okay, 1 meter, OCD. Okay, that was really bad. Okay, now, what is the rule of a triangle? The rules of a triangle are the sum of any two of the lengths must be more than the third length. So what does that mean? Let's say in this triangle, right? A, B, C. A plus B must be more than C. A plus C must be more than B. And B plus C must be more than A. Okay? So now we have to see, we can plug in A, B, and C for our numbers here. Okay. So I can erase the example that tells us how the triangles are set up. So we're going to say x plus 1 minus y is greater than y minus x. X plus y minus x is greater than 1 minus y, and y minus x plus 1 minus y is greater than x. Let me double check. We have x plus 1 minus y greater than 1 minus x plus y minus x greater than 1 minus, y, that was an ugly y. Y minus x plus 1 minus y is greater than x. Okay, cool. Now, so this one, like this one, these cancel. The y gets moved over. You get y is greater than a half. Here, the y's cancel. The x moves over. You get x is less than a half. But here you get 2x minus 2y is greater than -1. We're going to move the 2y over. So we're going to say 2y was less than 2x plus 1. And then, right, cool. And then, so then y was 1/2 divided by 2, right? So we can draw this out. Obviously, they're all less than 1 because the stake length is 1, so they can't be cut anything beyond 1 or before 0. So then we're going to make this okay. It's ugly, but it's fine. 0 to 1. Okay, this is the 1/2 mark. We said y was less than 1/2 x plus 1/2. So like this. Okay, that's the first line. Other line was y is greater than 1/2, and x was less than 1/2. So that's our region right here. And then for the other triangle, we set up the inequalities the same way. Y, like you can set it up the same way and you'll get similar equations. I think it's a bit redundant to redo the whole thing, but you're gonna get it was y is greater than 1/2 x minus 1/2, y is less than 1/2, and x is greater than 1/2. So when you basically draw it out again, you basically get this region. And each region, I know it's a little bit funky, the drawing. Each region here represents 1/8. And so then if you add them up, then you get the probability, which is 1/4. 1/4 of the overall probability space, or the support, which is like the mapping, like all the possible numbers in that the random variable yields you. 1/4 of them gets you a possible triangle. And so the probability of the 2 cuts creating you an eligible triangle is 1/4. All right, that's all.